Hello students, welcome to Board Maths Made Easy. In previous sessions, in part 1 video, we have seen Euclid's division algorithm. So any number A can be written as equal to BQ plus R, where A is a dividend, B is divisor, Q is quotient, and R remainder. And the remainder will be always greater than or equal to 0, less than our divisor. Also, we learned what is a prime number. A prime number means it will have only two factors, 1 and itself, whereas composite numbers will have, apart from 1 and 2, other factors also as a part of the number. Okay, we can do the product and then we can get the composite number. And also we learned divisibility rules from 2 to 12. Just I am trying to give you the list which we have gone through. Also, we learned fundamental theorem of arithmetic. So, what it says, every composite number can be expressed as a product of primes, and factorization is unique, and order doesn't matter. And then, how to do prime factorization? We know each number can be multiplied with prime factors. So, try to take out the prime factors based on the divisibility rules wherever it is possible. And the examples I have given, like when something is ending with 1, it may be 1 into 1, 7 into 3, or 9 into 9, etc. See, remember, I might have not covered each and every possible multiplication, but I just gave few examples. So, whenever you are thinking, don't think whatever I said that is the only limit. Like, suppose if a number is ending with 4, it could be a multiple of 1 into 4, 2 into 2, or 8 into 8 also possible. So, just take more and more exercises. While doing them, you will try to get more ideas. Also, we learned highest common factor. It's the product of the smallest power of common prime factors. And also we know HCF, it can divide all the given values. So HCF value is the least value among the given input values. Okay, when you find the HCF, it will be less than the given input values. Similarly, we learnt LCM, least common multiple. So what LCM does? Product of the greatest powers of all prime factors. It is not just common prime factors, it's all prime factors of all the input numbers. And LCM can be divided by all the given input numbers. These are the two things we learned. And also we learned one more thing, the important thing, LCM into SF is equal to given numbers product. Like suppose if A and B are given and their LCM and SCF is found, then LCM into SCF those given numbers is equal to product of the given numbers. So these are the things we learned yesterday. And also we learned LCM and HCF we can find using this formula only for two numbers. In case if you want to do the LCM and HCF for three numbers, this particular product rule will not be applicable. There is a separate formula that we will see as it is also one of the important formulas that we don't have many exercise questions, but we will learn the formula. And if there is any exercise you come across or example you come across, we can definitely apply that particular formula. So today we are going to learn irrational numbers. And what are irrational numbers? Any number which cannot be expressed in a format like a by b. Suppose if a by b, if a given number like say a by b is equal to say 1 by 2 or 7 by 9 or something 22 by 7, etc., etc., if we cannot we can write like this, then these are all generally called as rational numbers. And remember, irrational numbers we cannot write in such a format like a by b. Understood? If a number cannot be written in a format like a by b, then that is called as irrational number. Example is like root 2, root 3, root 5, pi. Pi you may say it is 22 by 7, correct, but it has no definite decimal. Okay, the definite decimal value will be keep counting. It will never be ending. If it is ending, usually these numbers will somewhere end. So certain numbers like 1 by 2, we know it, we can write it as a zero point 0.5. Similarly, other numbers, if a decimal fraction is never ending, then that number is called as irrational number. Okay, and here there are certain rules while understanding the irrational numbers and rational numbers. Usually, we prove the irrationality by contradiction. Contradiction means first you assume any given irrational number as a rational number. In that case, the rational number, say root 2, is a irrational number, but we don't think it as a rational irrational. We will say root 2, let us assume root 2 is rational. Okay, so if you assume rational, then root 2 can be written in a specific format like a by b. Okay, there are certain rules, like if a number a square we can divide with some constant, say uh, constant prime. Okay, some prime constant, not every one. If a given square number can be divisible by p, a prime number, p is a prime number, then a is also then a is also divisible by p. This is an important theorem we should remember. So what I am saying, when a square by p is possible, then a by p is also possible. Means we can do division like that. So this is going to play important role in proving our irrationality of numbers. So to prove root 2 is a rational or irrational, what we do, as we said previously, we will assume root 2 is equal to is a rational number. Okay, we assume it. So if root 2 is equal to a by b, because why we assume like a by b, we said that any rational number can be represented in the format a by b. That is the reason. And I will square on both the sides. What will happen if I square both the sides? Root 2 whole square is equal to a square divided by b square. So what will happen? A square is equal to 2 times b square. So what it means, b square is equal to a square by 2. If you recall, if a square of a number is divisible by some value, then it's a square, not just a value, a prime. Like here, if you remember, when a square is divisible by a prime number, here 2 is also prime. Then a is also divisible by prime. Correct? That means a by 2 is also possible, and let us assume that is a some c. Correct? So that means a is equal to 2c. Okay, so why? Because we have learned two things there. When you are assuming something as a rational number, you can represent it in the a by b format, and I squared it here both the sides, and a square is equal to 2b square, so b square is equal to a square by 2. Here I am not thinking what is the value of b square, what is the value of a square. I am thinking that a square is divisible by a prime called 2, then a by 2 is also possible. If a by 2 is possible, what is that value? Let us assume that as a some c. That means it will give me a value called a is equal to 2c. For such a value, okay, we can represent, like we will replace it in the given equation. Till that point, are we clear? Okay, so if we substitute a value in the original equation which we have squared, a square is equal to what? 4c, or I shall say 2c whole square is equal to 2 times b square. So b square is equal to 2b square is equal to 4 times c square, b square is equal to 2 times c square. So what does this give? See, our initial values are only a and b. So c square is equal to b square by 2. Here c is something we assumed in between. Okay, so in between it is just some arbitrary thing. Okay, so we don't focus much on this. Here we need to focus on this particular thing. What here we are doing, b square is divisible by a prime, that means b is also divisible by prime. So a in root 2 is equal to a by b. A is divisible by 2, b is also divisible by 2. But while assuming, there is one important principle we need to understand. A number, when you are representing any rational number in a format, like suppose if I say, sir, 4 by 6, how do you write? You don't write 4 by 6, you will write it in its prime factor method or format. Okay, why? Because 4 by 2, 2 into 2 divided by 3 into 2, 2 get cancelled, so 2 by 3. That means whenever you are representing a rational number, you will have always its prime factors only in the numerator and denominator. So you cannot have again, like if this is the case, you can represent, you can multiply this with 1000, 2000, 10,000, any number. That is not what we want. We need to know the exact fraction. That is possible only if you are making it into the prime factor. Similarly here, when you are writing root 2, you are writing them in a is a prime factors, b is a prime factors, and they both should not have any kind of common prime factors because they get cancelled. That is called as a and b are co-prime. A and b are co-prime. So when you are assuming root 2 is equal to a by b, the assumption is that a and b, a by b are, I am assuming root 2 is rational and I can write it in a by b format such a way that a and b are co-prime. That means they do not have any common prime factor which I can cancel out. Okay, but here, because of that assumption, what we have done all this calculation here. We have done a square, like we have done the squaring on both the sides. Then what we got, a square is equal to 2b square, and we know the principle. When a number is when a square of a number is divisible by a prime, then even without square also the number is divisible by prime. Similarly, we derived here b square is equal to 2c square, and b square is also divisible by 2, b is also divisible by 2. That means what happened here, when we come back to this particular point, here in the above formula, we are getting a and b have a are both divisible by 2, a by 2 and b by 2. But when we assume root 2 is equal to a by b, a and b are co-prime and they do not have any common factors. When we can divide, if a is something 2 into some x, b is equal to 2 into y, that means 2 into 2 get cancelled. That means a and b are still having some common prime factor which we can later cancel out. This contradicts the rule because the rule is a and b are co-prime. They cannot have any common value. But by assuming root 2 is, I can write it as a by b, and you have done all this exercise, you are proving that there is a common factor, like a and b both can be divided by 2. So that contradicts the a and b are co-prime. That means your assumption is wrong because you are assuming root 2 is rational and writing in a format like a by b, and you are writing it as a by b, and by doing the squaring you are getting the value which contradicts. There is no common factor which can be cancelled in a and b. Correct? So this is called, so why the, because you said it is root 2 is rational and a by b is my possible value, but a and b are co-prime, but after all the exercise you are saying that a is equal to a is divisible by 2 and b is also divisible by 2. So this contradicts because A and B have no common factor. But here A is divisible by 2 means you can write A as A by 2, B as a B by 2. So this get cancelled. That means there is something still common left. But A and B are co-prime. They don't have any common. They don't have any common when you assumed, but you are getting something as common present. So this contradict your own assumption that root 2 is rational and I can write it in A by B format. That your assumption is correct. That is the reason root 2 you cannot write in a format called A by B. So root 2 is irrational. That means you cannot write root 2 kind of number in A by B format. Okay, this is the same exact logic everywhere you apply whenever you are using root 2, root 3, root 5, because these are the three irrational facts numbers we are going to deal in our topic. Rest of the things are not in our scope and don't worry about them. I hope you all understood the irrationality and contradictory method. Okay, assuming something as rational and unable to prove it is rational, so finally agreeing that yes, our assumption is wrong and root 2 is irrational because it doesn't comply to the rules of rational numbers. Similarly, exact same thing will be there for root 3 and root 5. And also we have something like addition or deduction, like 5 minus 2 root 3 is irrational, prove it. See, root 3 if you are proving, for a irrational number you add anything or you subtract anything, naturally it will be irrational number unless you are subtracting the same number. Suppose you say 2 root 3 is equal to 2, like 5 plus 2 root 3 is equal to 8 plus 2 root 3. It is never possible. Why? Because 5 is not equal to 8 and 2 you are adding 5 plus 2 root 3 is equal to 8 plus 2 root 3. So 2 root 3 will get cancelled and 5 will become 8. It is never possible. Instead, if there are two terminologies like say a plus 2 root 3 is equal to b minus 2 root 3, then prove that these numbers are irrational. In that case, a and b are variables, and depending on the value of a and b, the number may be rational or irrational, but let's not get confused with those things. We will only work through the examples when we come to exercise, and we will see what are all those possibilities. The next part is about three number LCM and HCF. We have two important formulas for these two things whenever there are three numbers are given. Okay, we know how to find LCM. LCM is the greatest powers of prime factors, whereas HCF is the least powers of the product of the least powers of the common prime factors. Okay, so these we have already learned. Now in case if they are giving you three numbers, okay, how do we find the LCM, how do we find the HCF, and are there any formulas? This we will see. Remember, we are not going to use any shortcut method for finding the LCM or HCF of three given numbers. LCM, if they have given three numbers, whatever the numbers, like say 12, I think we have done 12, 18, and some 54. So there we have, like LCM is greatest product of the greatest product of greatest powers of factors. So if 12, 18 and 54 are given, in this we will write 2 square into 3, this we write 2 into 3 square, and this 2 into 27, right? 27 is 3 cube. So product of the greatest powers of factors in this case is, see here we are not using two numbers, we are using third number also 54. So here for each one you need to write the prime factors, the given number as a product of the prime factors. Similarly, all the three numbers you must write and apply this rule, product of the greatest powers of the factors. So here What is the greatest of the factor? In this 2 and 3 are common everywhere. So 2 I will take, 3 I will take, and here the greatest power of 2 is in all these 3, it is 3 only, and then for 3, 3. So the LCM value of these 3 is 2 cube into 3 cube. That means 108 is the value. And if you recall the tip, LCM can be divided by all the given numbers individually. Like 108 can be divided by 12, 108 can be divided by 18, and 108 can be divided by 54. And if we have to find the HCF of the same numbers, how do we do? HCF is the lowest product of the, okay, let us write this term, product of the least powers of the common prime factor, powers of the common prime factors. See, we are talking only in terms of prime factors, not just factors. Okay, so here, so for same 12, 18 and 54, what are my 2 cube into 3, 2 into 3 square, 2 into 3 cube. So in this case, common prime factors in all the 3 is 2 and 3. 2 is there in all the 3. 3 is also present in all the 3 numbers. So here we need to take the least. Okay, for 2 and 3 I need to take the least powers. Here it is a cube or square. I think it's a square. That's okay. Okay. Okay, 2 square into 3. Here 2 into 3 square and 2 into 3 cube. Here the least power is of 2 is 1 and least power of 3 is again 1. So the highest common factor is only 6. So LCM and SCF we have found for 3 numbers, not a 3-digit number. Three different numbers are given and asked for LCM or HCF. You need to do this manual method only. There is no direct formula unless they have given you some different information, and for that there is a formula which I'm going to tell you. Okay, so it's a bit bigger formula. What I'm trying to write you is equal to, if they have given LCM of say PQR, they're asking in this case. Okay, if they are asking LCM of PQR, you and given the numbers PQR is given. Okay, so here you are writing P into Q into R into HCF of P comma Q comma R. See that here what you are doing, P into Q into R into HCF of P into P Q R divided by HCF of PQ. These dots don't confuse it. These are not products. These are our highest common factor. Just okay, HCF of P comma Q and multiplied by HCF of Q comma R multiplied by HCF of P comma R. Okay, so this is the way you can find the LCM of 3 numbers if they have given you PQR value. Okay, but to find this way, what you have to do, you have to find the HCF of PQR, all the 3 numbers, then each 2 numbers you need to find for HCF of PQ, HCF of QR, HCF of PR, and also HCF of all these 3 numbers. Then multiply the PQR with P into Q into R into HCF of PQR divided by HCF of PQ, HCF of QR, HCF of PR. This is a lengthy process. Instead, The earlier example we have seen, right? Simply you directly go and find the LCM in a manual method. That is much more faster. Unless they ask you specifically to use using the formula. Okay, actually there is no such question in our exercise anywhere, but I tell you, rarely they will ask some questions in this kind of format. If at all, they are going to ask for a higher marks. Okay, this will test your knowledge. So, knowing the subject is always good, even though you may not use these kind of formulas. Similarly, SCF of PQR, same, exact same thing. When LCM is given, you are doing finding the SCF, okay, of the three, and then both like PQ, QR, PR, HCFs. In this case, what you will do, you will do P into Q into R into LC. Yeah, we are asked to find the HCF LCM of P comma Q comma R divided by LCM of P comma Q into LCM of Q into Q comma R into LCM of P comma R. I am sure compared to these formulas, our methodology like to find the LCM for three numbers is much more faster and easier. But for the knowledge sake, don't forget to learn the formulas. You don't need to do anything much actually using the formulas. As far as I know, there is no specific question in the NCERT books. But if at all you get a question, okay, what you need to know is LCM of PQR is equal to PQR into HCF of PQR divided by HCF of, take two at a time, HCF of PQ, HCF of QR, HCF of PR. Similarly, if they are asking HCF of PQR is equal to PQR into LCM of PQR divided by LCM of PQ, LCM of QR, and into LCM of PR. So this is the methodology. I hope this will clear you the concepts, and we are done with almost all the concepts in this real number system. I mean to your class only. So in the next video, we are going to work on the exercise 1.1 and exercise 1.2. They will not be this lengthy, but we will try to see all the problems solved by ourselves. Okay, thank you so much. We'll catch up on the next video. Thank you. Good day.